Welcome back to the Punny Math Teacher, where we make genius happen, like wrapping yourselves in earbuds, because that's how you make a microphone centralized when you're left-handed and your mic is on your right earbud. So, expectations, please use twice this video's length to take notes and wonder. Today's, it will be just one page. Next one will be 2 pages, so I'm going to try to make these, all the short ones, short. That way we can at least make up for the time later when you use twice the video's length to make sure you're pausing and thinking about it. I know I talk fast. You can always slow down the playback speed if you hit the Loom link, and then also just making sure that I don't just have wait time and dead space for you, so every second is used, so you can pause and create that wait time as you need. That way it's customized to how you learn, and it's not just you sit there and wait for everybody. So that's the goal of flipping, and our next thing. So this lesson will actually lead into our next lesson as well. So the objective's the same. Our end goal after the next 2 videos, this one and the next, is for you to differentiate between a relation and a function, and when they're actually the same thing. So what makes them different, but what makes them similar, and then I have those prepped. So moving on to table of contents. Relations is today's, and it's page 22. So make sure that you are labeling your table of contents and labeling your paper. So relation. We're going to define it first. So a relation is a set of ordered pairs. All right, and now we're going to draw a bunch of examples, because you can write a relation or draw a relation in lots of different ways. So an example is we use fancy brackets or braces to say it's a set. So those are a set notation, having those brackets. So an example would be having 4, 3, -2, -1. Let's hope I can get all 4 of these in here. And 2, -4, and 0, -4. Boom. So this is a set of ordered pairs. I know it's a set because it has the braces. I know they're ordered pairs because they're all in parentheses. And so this is an X, this is a Y. -2 is an X, -1 is a Y. 2 is an X, -4 is a Y, 0 is an X, -4 is a Y. All right, so I'm going to write a random note off of here for our next one. So for future reference, when we actually know what this word means, this is a function. All right, so this is an example of a relation, but for future reference, this is also specifically called a function. So random FYI. Okay, another way we can write it beyond a set is with a table. So if I have a table of my X coordinates and my Y coordinates, I could write this as 4 is an X, 3 is a Y. -2 is an X, and it's paired with the -1. So they have to go with each other. Now I could scramble the order if I wanted. That doesn't matter, but the X has to be paired with its Y coordinate. Otherwise, it's a totally different point or totally different location on our graph. And then we can also use what's called a mapping. So a mapping takes our domain and maps it to the range. So our domain is going to be all the set of X's that we use, and range will be all of the Y values that we use. So domain is going to be 4, -2, 2, and 0. Those are all of the X values, X coordinates we're using, and the range they get mapped to. I'm going to go in order just so you can see how they are fun-loving. Okay, so, I guess they go in order. 3, -1, -4. Okay, so 4 maps to 3, -2 maps to -1, and then both of these map to -4. There we go. So it's a mapping. We get to exactly see each input goes to each output, which we're going to use that notation and vocabulary a lot in the next couple lessons, especially in the next unit, with inputs and outputs. So domain we can write in set notation as well. Domain is going to be, and typically we write it from least to greatest. You don't have to, but you can. And range, and you could write the duplicates if you wanted, but it's similar to not, so you don't have to. And then you can also show the relation as a graph, which we started learning about how to plot points last lesson. So, and you're going to draw so many axes, you're going to get so good at this. So remember to put arrows. And this is remember our x-axis and our y-axis. And let's plot them. So I'm going to plot 4, 3 first. So I'm going to go 1, 2, 3, 4 to the right, 3 up. I'm going to go -2, so left 2, down 1. Try the next 2 on your own. 0, -4, and 2, -4. So this is a relation seen as the actual locations on a coordinate plane, or Cartesian plane, or coordinate grid, or Cartesian grid. They're all interchangeable. Okay? So just an FYI on your graph, make sure you have arrows on your axes. Remember, axes is plural for axis, 2 of them. And then if your scale is by 1, because we're going 1, 2, 3, 4, no need to label. It's assumed this scale is 1, 2, 3, 4. If I was going by 2s, 2, 4, 6, 8, I would have to label them. I'm going to cross those out though, because that's not legit. But if I was going by any other scale than 1, I would want to label it so I can communicate to others reading my graph and reading my data that this is what it is. I don't want to just mislead them. I'm like, oh, it's a line. No, it's not a line because I messed it up with transforming my axes. And then, what's the other thing? Gotcha. If only given a set of ordered pairs, only plot points. So we were only given a set of ordered pairs. I was not given a pattern that these pairs have to follow. If I'm given a pattern, i.e. a function, if I have to give it a pattern, then I know I can connect them. There's a bunch more, there's infinite solutions to that equation, but because I'm only given 4 points, I can only plot 4 points singular, no connecting them, that's it. It's just points. All right, and the x-axis is where we label the independent variable, which I hope you've seen that phrase before in science class. So x-axis is independent variable, which is typically time. And then the y-axis is whatever else that you are measuring, which is your dependent variable. So like the height of a plant over time, the position that you are away from school at time. So time is a huge one, but like how much you get paid over time, or how many shirts you're buying, what's the price of your bill. So the x-axis is always something incremental. It's independent, it will stand by itself. Dependent depends on how many shirts you actually put in your order and how long you're actually letting your hair grow to see how long it's going to be, etc. So, we don't have the card sort here. If we are in a physical classroom and I am your actual teacher, we would be doing a sort just to see what are examples of independent and dependent variables. I just gave you some. So the independent variable is typically time, but it could also be like a number of shirts ordered. Dependent variable could be height or length of hair. It could be anything and everything, like a whole bunch of stuff. It could be your total bill. And I want you to find one more. What's one more independent variable? And then what's a dependent variable that would make sense with that one? And comprehension questions. I want you to create a song or acronym to define a relation. Because you've seen relations now for this lesson, the next one will be function, and then I want you to make a song or acronym that compares them both, and then teach them to somebody and explain what it means. That way they're not just singing random words. And then I want you to think, why are functions preferable? Even though when we collect data, it might actually be in the form of relation, typically, like a scatter plot. So why do we like functions? Keep that in mind for our next lesson. All right, thank you for watching and have a great day.